Today we're going to be talking about density. Specifically what we're going to be looking at is beverage density. To start off the lab, we're going to go through some of the materials. What we're going to need for the lab, first we're going to need a 10 milliliter graduated cylinder. We're going to use this instead of using the pipette in the directions. Next piece of material, we need a 100 milliliter beaker. And then what we're going to need is we're going to have 4 reference solutions that we're going to be using throughout the lab. All right? Our reference solutions have a mixture of distilled water and sugar, and they have a % of sugar per color. The first color, blue, is going to be our smallest percentage. It's going to have only 5%, and then our yellow is going to have 10%. Then our green will have 15, and then our red will have 20. So we'll kind of switch these around to go from low to high. And what we're going to use these for, these are going to give us a reference sample. And it's going to give us a graph that we will use later to help us determine the % of sugar in 2 different beverages. The first is going to be apple juice. And then we have Hawaiian punch. To begin the lab, we are going to first start off by measuring the density of distilled water. You'll find the distilled water on your desk in the squirty bottle. And what we're going to do is we're going to take our graduated cylinder and we are going to measure exactly 10 milliliters. Then what we're going to do is take our 100 milliliter beaker and we're going to place it on our balance. And we're going to zero out the balance. After we zero it, we're then going to add in our distilled water. We put it back on the balance and we measure the mass of the distilled water. Watching this for your pre-lab just to see the procedure, you don't have to write that down, but if you're doing this as a makeup, make sure you're writing this down in your data table that was provided you in your lab. Now, we're just going to pour that out down the drain, and we're going to start back with our reference samples. And we're going to start with the least amount of sugar, which is 5% of sugar, and we're going to go ahead and measure out another 10 milliliters. Now that we've measured out 10 milliliters, we're going to go ahead, take our 100 milliliter beaker again, put it back on our balance, and zero it again, and then pour in the 10 milliliters of the 5% sugar solution. We put it on the balance, and we record its mass. We see that it has a mass of 10.06 grams. We can go ahead and pour this down the drain again. Make sure every time you pour it down the drain that you put a little bit of water behind it just to wash it down nice and good. We're going to go ahead and then move on to our next sample solution, which is our yellow, that has a 10% mixture of sugar and water. Go ahead and measure out 10 milliliters of that. We're then again going to take our 100 milliliter beaker, put it back on our balance, zero it out, and then we're going to add in the 10% mixture of sugar. Put it back on the balance and record its mass. And we see that it has a mass of 10.37 grams. So we see that the mass has gone up in this 10% mixture. We can again pour this down the drain. Now we're going to measure it with the green or the 15% mixture of sugar. Go ahead and pour 10 milliliters again. And again we're going to add it to our 100 milliliter beaker, put that on the balance, zero it out, add it to our beaker, and record the mass. And we see it has a mass of 10.42 grams. Pour it down the drain. And we're going to finish with our reference samples by finishing with the red, which has 20% sugar. Go ahead and pour 10 milliliters. Go ahead and take our beaker again, put it back on the balance, zero it out, and add the 20% sugar solution. And record its mass. And we see that it has a mass of 10.64 grams. Again, it went up. So what we've seen from all the reference samples is that as we've increased the amount of sugar, the density of the liquid has also increased. The mass of it has increased. So therefore the density increases as well. Now what we're going to do is we're going to take our two unknown samples, and I'm going to go ahead and give this a quick rinse so that the graduated cylinder is nice and clean for our unknown samples. Now let's take our first unknown concentration of sugar, and this is our Hawaiian Punch, and we're going to go ahead and do the same process, and we're going to fill up 10 milliliters in our graduated cylinder. Now we're going to take our 100 milliliter beaker, put it back on our balance, zero it out, and add our 10 milliliters of Hawaiian Punch. And now let's record the mass. And we see that the mass of the Hawaiian Punch was 10.21 grams. And guys, it's okay to pour it down the sink. Just put a little water behind it. Now we're going to go ahead and test our other unknown sample, which is our apple juice. And we're going to go ahead and again pour it in our graduated cylinder, and we're going to get 10 milliliters. We're going to again go ahead and take our beaker, put it on the balance, zero it out, and add our 10 milliliters of apple juice. And record the mass. And we see that the mass is kind of going back from 24 and 25, so we're going to go ahead and say that it's 10.25 grams.